Today we are going to do a little troubleshooting using the Simu gas simulator to simulate a service call. So this particular customer is dealing with a high efficiency condensing type furnace and is complaining that the burners remain off. However, the blower runs only if the fan is in the on position. So to begin troubleshooting this particular piece of equipment, we always need to make sure that the thermostat is calling for heat. So we're going to come over, we're going to come and check and verify using our meter that the thermostat is indeed calling for heat. So the first thing we got to do is we got to make sure that we have power across our circuit. So yes, we have 115 volts. Why don't we go and double check a few things before we troubleshoot our thermostat? We have 115 volts coming into our equipment. What about our transformer primary? Do we have 115 volts at our primary? Yes. What about on our secondary side of our transformer? Are we even getting 24 volts out to our thermostat? Okay, so we are. So we can verify that we do have 24 volts, but is the thermostat actually closed? So in order to do that, we're going to take and we're going to go across our R and our W. Okay, so we have 0 volts. So that indicates that the thermostat is indeed closed. So we look at this wiring diagram, we can see out of W, we go into two different directions. We go into our heat relay coil, which is going to energize this set of contacts, which should turn on our vent motor. So did our vent motor actually come on? Our vent motor is on. Okay, so that's a good thing. So what happens after that? Our vent motor comes on. We know through sequence of operation that we have to have a pressure switch. That pressure switch needs to close, and that pressure switch is called the vent pressure switch, which is up here. Okay, that vent pressure switch is there to prove that we actually do have a draft going through our heat exchanger and out the flue pipe. It's proving that the flue pipe in the heat exchanger is not plugged. So we need to verify in our next step of operation here is our vent pressure switch actually closed? So let's come over and let's verify to see if the vent pressure switch is actually closed. The vent pressure switch is actually closed. It's reading 0. Because remember, voltage across a closed switch is always 0. So we know that our vent pressure switch is closed. It's doing its job because the vent pressure switch, the vent motor has actually started to spin. So we know that that's good. Our next one would be our rollout switch. Is our rollout switch closed? Let's see. Okay, so we got 24 volts there. Let's see. Let's go right across the actual vent rollout switch. What is that going to tell us? Is that closed? Let's go across. 1. Vent pressure switch is closed. The reason why we are reading 24 volts from that last part is because we are reading across the ignition module. The ignition module in this case is actually a load. Okay, so we are reading a load. So that's telling us that we do have power here, but we just want to verify that all of our pressure switches are indeed closed. So let's go across our high limit switch. Let's go across here. High limit switch is closed. Okay, so our vent pressure switch, roll-off switch, and high limit switch is closed. So therefore, we should be receiving power to our ignition module. Let's go across our ignition module with TH and TR. 24 volts. Okay, so there's our power. Comes in, it's coming back to our common. So that's why we were reading that 24 volts from that previous reading. Okay, so we know that our ignition module is getting power, but how come we are not energizing? We can see in this case our ignition hot surface igniter is glowing red, but we are not getting any sort of flame. So what is going on here? You can hear the click, and we are not igniting. Well, what's going on? Well, let's come over. We know that we are getting ignition. Okay, so that is right here, our L and our igniter right here. So we know that we are getting 120 volts to our igniter, and our igniter is working. So it can't be this portion of the circuit. It's got to be something over here that's causing the furnace to not fire. So what about our gas valve, our MV? Are we getting anything to our MV? 0 volts. Well, look what happened here. We got a light. We got a flashing light here. What is that telling us? Did everything shut down? Our vent motor is still working, but now I'm getting a flashing light. The flashing light on any ignition module is going to indicate that the module is locked out. Okay, so in order to reset an ignition module, we have to shut the power off to the entire piece of equipment and let it sit for a couple of seconds and let everything reset itself, and then turn the power back on. And that will now reset the module to think that everything is clear. So we're going to turn the power back on, okay, and we're going to wait. We're going to see. We have our vent blowers on. We heard the click. Everything is good. Our hot surface igniter should start to glow. Give it a couple seconds. Okay, hot surface is glowing. But do I have 24 volts, which will now energize my gas valve? We are not seeing the 24 volts going to our gas valve. Oh, well, there it is. Okay, so we do have power coming to our gas valve. So why didn't it ignite? Well, let's come down here. First thing you should always check when you're looking at a gas valve is the gas valve in the on position. Okay, just because we are receiving power from the ignition module down here, gas valves have a little dial on there, and they do need to be in the on position in order for them to work properly. Okay, so we're going to try that again. We're going to come over here. We're going to let it go through its sequence of operation one more time. It's trial for ignition is what it's called. Okay, many of your high efficiency condensing gas furnaces are going to have a trial for ignition of probably about 3 times. After the 3rd try and it doesn't light, it's going to go into that lockout period. Okay, so we're going to sit here, we're going to wait for that hot surface igniter again to start to glow, and then we're going to see whether or not we are actually getting any flame now that the gas valve is in the on position. Okay, here's our hot surface, glowing. Nope, still no gas. Gas valve did not open. Okay, so let's see, what do we have going on? So we know that there's got to be a problem with the gas valve now, because we now know that the gas valve is in the on position and we are receiving 24 volts to it, but yet it did not light. So what we're going to do is now we are going to come over and we're going to shut the power off to everything. Okay, we can even shut the gas valve off to the off position if you so choose. Not that big of a deal. And now we are going to use an ohm meter. Our ohm meter is now going to verify whether or not our coils inside our gas valve are good. So let's go across our gas valve. We are receiving 20 ohms of resistance. So that's telling us that the coils inside that gas valve are still good and are being energized. But why didn't the gas valve send gas out to our main burner so that we can light? We need to take this troubleshooting just a little bit further. This does not appear to be an electrical issue in this type, because we have just verified that we do have 24 volts. Our thermostat is closed. We know that the relay is good, and we can always verify it. Okay, let's go to our heating relay. Okay, and let's just double check that. Look at that, we got 20 ohms. So our coil for our heat relay, which is controlling our vent motor, is good, because we know that the vent motor is spinning, and we did troubleshoot the vent pressure switch, roll-off switch, high limit switch, and we did verify that every single one of those was closed, and we did verify that we were getting power to the module. So it can't be that. So it's got to be something with the gas valve. So what we're going to do is now we are going to remove our ohm meter, and we're going to come back over and we're going to look at this gas valve. We know that is the gas line on? The gas line appears to be on, because see, we got the little blue. So it seems like we are getting gas pressure to the gas valve. But what we're going to do is I'm going to shut the gas valve, the main gas valve, off, and I'm going to put my manometer on. I'm going to put my manometer on here, and then I'm going to come over and I'm going to turn on my gas valve. Okay, I'm getting 7 inches of water column into my gas valve. So I know that I got a gas supply. But what about on my outlet side? So let's take this and we'll go on to the outlet side of my gas valve. Let's see what's going on there. Okay, so let's go back. We're going to turn the gas valve on. We're going to turn the power on. Okay, and we're going to let that again go through its sequence of operation. Okay, vent pressure switch is closed, vent motor is on. So now all we got to do is wait for the timing, and we're going to wait for our hot surface igniter to again glow. Okay, because we do need to have our heat source in order to ignite the gas. And then we're going to see whether or not gas actually does flow through the gas valve to the module. Okay, now if it does open, we are looking for inches of water column of about 3.5 inches of water column. If it doesn't open, then we know that there's a problem with the gas valve. The gas valve is actually mechanically bad, which means somewhere inside there's a mechanism that is just not allowing the gas to flow through. Okay, look at that. We heard the click. We heard that the gas valve should have opened, and I'm not getting anything. I got 0.0 inches of water column coming out of the gas valve. So we have found our problem. We have found that the gas valve is actually mechanically bad. Because now remember, we troubleshoot, and we troubleshooted the transformer. We verified that the thermostat was indeed closed, and we did verify our coils, our switches, and the module. So we know that all of that stuff was good, including the coil inside the gas valve. So a electrical issue. This is a mechanical issue. Again, inside of this gas valve is a mechanism. Once we apply power to it, it's supposed to open, allowing gas to flow through to our manifold. But we were not receiving that. So we have to come over and we need to figure out exactly where our problem is. So we know that the igniter does glow, but the burners will not ignite, right? So let's go over here first. Let's see. We did verify that the gas control was on. We did verify that we did have gas. We know that we did not have a low gas pressure because we did have, what, 7.5 inches of water collar coming in. We verified that we did not have an open gas control valve coil because we ohmed it out, and we were receiving 20 ohms of resistance across it. And we now verified that we have a mechanically bad defective gas control. Somewhere inside that valve, something is broken and is not allowing the gas to go through. So we're going to click that, and we're going to repair. We're going to replace the gas valve. Okay, we have completed it. And now let's test our control. Let's put the gas valve on. Let's go through, put the power back on, and now let's see what actually happens. Okay, we heard the click. We heard our vent pressure switch close. So we are now sending power to our ignition module, and now the ignition module is now going to go through its timing to then send out the ignition sequence, setting up our hot surface igniter, letting that glow, and then it should send the signal to the gas valve, sending it and telling it to open. So we are looking at a reading of 3.5 inches of water column roughly through our manifold. So let's see what happens. There you go. 3.5 inches of water column coming through. I now have fire. Okay? I have now successfully repaired my my gas valve, and I have now successfully completed my service call. We had a defective, mechanically bad gas valve. My system has been repaired, and I am one day a hero.